Let us look at question 4 now. Right? So here is a solution of question 4. So what are the issues here? Well, the first issue is that the Erdős-Rényi random graph is generated in a loop. Now, this happened because students, well, just reused my own code from the introduction part of the lab handout. But what is wrong about it is that the purpose of my own code, well, the primary purpose was not to create an Erdős-Rényi random graph, but to demonstrate a concept. So it was to create the animation, not the graph itself. And this code uses a loop and an if condition inside the loop. And first of all, it's hard to understand. And second, it's very inefficient. It's just slow. So if you, well, what you're supposed to do, you're supposed to Google search for the right command in the right graph generator in the NetworkX package. So there is just a native function in NetworkX package that just generates an Erdős-Rényi random graph. But if you did not want to do that, at least you could have reused your own code from exercise 1, right? So instead of doing this, we could have done this. And G is X. So that doesn't really change anything, but it makes the code much more efficient. So then, again, we have this issue that the explanation in human language is a commented code rather than a special markdown cell. So let me type it into a markdown cell. Well, and the third issue is that, well, it says the distribution of the vertex degrees is normal distribution. So the shape of the graph looks like a normal distribution. I mean, it probably looks like a normal distribution, but it doesn't mean that it's the normal distribution. So this is an observation rather than an explanation. And here I was looking for a rigorous proof of the fact that this is binomial distribution. It's not normal distribution, binomial. Because, well, and then a rigorous proof. So a rigorous proof here is very simple. Is just because the degree of a vertex is the sum of entries of all entries in the corresponding row or column, and entries of the row or column are Bernoulli random variables. So it's the sum of independently distributed Bernoulli variables, which is the definition of binomial distribution. So I wanted you to type this. So that's all about question 4. So the main takeaways are, if you are reusing previous code, then please do it wisely. Then read the question carefully. And again, human language goes to markdown cells, and Python code goes to Python cells.